Here's one
of a
example.
quick return mechanism.
This is a crank and slotted lever mechanism where this is the crank. This will turn fully 360 degrees. Because of this turning, this slider in this slot will move along the slot, and that slotted lever is going to be pivoted around this point, which then pushes this just like a slider crank mechanism, and this moves back and forth. Um, as we had noticed in a crank rocker mechanism, once this full rotation of crank happens, the rocker goes between two extreme positions. The forward and return strokes, meaning the in the crank rocker, this crank going from this extreme to the other extreme, this extreme to this extreme, meaning going from this position all the way to this position and then coming back from this position to this position. So each of these strokes was taking equal amount of time as for a given constant input angular velocity. So this was forward stroke equals return stroke time. For some mechanisms like a shaper, where the forward stroke is more important, it's the stroke which does the work. And sometimes when a cutting tool needs to go um, do the cutting operation, that stroke is required to go slowly, but the return stroke is not doing any work, so the tool can come back fast. So such kind of mechanisms, you can use quick returns so that the forward stroke goes slowly and the return stroke comes back fast. In order to find out what is the ratio of this so-called forward stroke duration to return stroke duration, we can simply use position analysis, and we can find the two extremes at which the slider is at the end of the strokes. And you can quickly notice that during this rotation, one extrema is where both extremas are where the axis of this slotted lever is tangential to the uh, circle marked by the crank. At these points, at one end you would see the slider like this, and the other end would see the slider all the way on the other end of the stroke. So this portion is the total stroke. Timing that we are interested in finding out is how much time it takes to cover this angle versus this angle. So the forward stroke giving the longer duration. Uh, if we if we see this is a tangent, then this is simply 90 degrees. So if we want to find this angle, let's say the half angle is theta, then we can write cosine of theta is equal to the crank radius divided by this ground link. So we can obtain theta from this. We can double that, and this is 360 minus theta. So if we say beta is uh, the half angle here, we can say beta over theta is the quick return ratio. So that's a brief idea of overview of the quick return mechanisms.